The ground beneath us, solid and seemingly eternal, is anything but. From the tectonic plate shifts that forge mountain ranges over millennia to the subtle creep of erosion, our planet is in constant flux. But what if that change wasn't measured in geologic time? What if a single machine, operated by a handful of people, could move enough Earth to redraw a landscape in a matter of weeks, or even days? We often think of construction in terms of static buildings, of materials being assembled. But beneath that, there's a deeper, more fundamental force at work, the raw, immense power to sculpt the very face of the Earth. These are not merely big machines, they are instruments of geological transformation, each designed to overcome forces of friction and gravity on a scale that defies easy comprehension. Today, we delve into 5 such titans, machines so powerful they don't just build on the Earth, they literally reshape it. Number 5, the roadheader. Imagine descending into the unyielding heart of a mountain. The air grows thick, the light fades, and before you stretches an impenetrable wall of rock. For centuries, this meant explosives, pickaxes, and drills, slow, dangerous work. But then came a different approach, a machine that doesn't blast, but rather chews. The roadheader is a specialized tunneling machine, often seen in mining operations or the construction of subterranean infrastructure like subway tunnels. It doesn't bore a circular tunnel like a tunnel boring machine, but instead excavates a rectangular or arched profile. The engineering trick lies in its cutting head. Picture a massive, rotating drum, studded with hardened tungsten carbide picks. This drum, often weighing several tons, spins at speeds that, while not incredibly fast, generate immense kinetic energy. The picks themselves are designed for sheer brute force, they chip and gouge at the rock face, not unlike a giant, mechanized chisel. A typical mid-sized roadheader, like a Sandvik MR360, can exert a cutting force of over 100 kilonewtons, tearing into rock with a compressive strength of up to 120 megapascals. That's enough to rip through layers of hard shale and even some types of granite. The entire machine moves forward on robust crawler tracks, systematically sweeping its cutting head across the tunnel face, shaving away layers of rock. A conveyor system then carries the excavated material, known as spoil, away from the cutting face. The real ingenuity is in its precision. Unlike explosives, which create unpredictable fragmentation and can weaken surrounding rock, the roadheader excavates with a controlled aggression, allowing for safer and more stable tunnel construction, often leaving behind a smoother, more intact tunnel wall. It's not about a single, massive impact, but a relentless, grinding persistence that wears down mountains one chip at a time. Number 4, the rock haul truck. The sheer scale of an open-pit mine is difficult to convey in words. These are vast, terraced bowls carved into the earth, often miles across, designed to extract minerals hidden deep below. But once the ore is dug out, it needs to be moved. Not just a few tons, but hundreds of thousands, sometimes millions of tons, every single day. This is where the rock haul truck enters the scene, a behemoth designed for one purpose, carrying more material, faster, than anything else on wheels. The engineering challenge here is overcoming gravity and friction on an epic scale. Consider a Komatsu 980E 5SE, one of the largest electric drive haul trucks in existence. This machine can carry a payload of 470 tons of rock. To put that in perspective, that's equivalent to the weight of over 300 standard passenger cars. The truck itself weighs roughly the same amount when empty, meaning its gross vehicle weight can approach 1,000 tons. Moving that mass requires power, enormous power. Its diesel engine, for example, is not directly connected to the wheels. Instead, it acts as a generator, producing over 3,500 horsepower to power massive electric motors located in each of the rear wheel hubs. This electric drive system offers immense torque from a standstill and precise control, crucial for navigating steep haul roads. The tires alone are over 13 feet tall, each weighing over 12,000 pounds, and cost tens of thousands of dollars. The braking system is equally staggering. Imagine trying to stop a 1,000-ton object rolling down a 6% grade. It doesn't rely solely on friction brakes. Instead, the electric motors themselves become generators during braking, feeding power back into resistor grids that dissipate the energy as heat, a process called dynamic retardation. This saves the enormous mechanical disc brakes, which are themselves the size of small car wheels, for emergencies and final stops. These trucks are not just transporters, they are mobile power plants, engineered to conquer the laws of physics with every loaded trip. Which of these machines would you least want to be standing next to? Tell me below. Number 3, the open-pit mining shovel. If the rock haul truck is the brawn of the mine, the open-pit mining shovel is its outstretched hand, capable of scooping mountains. These aren't your typical construction excavators, their scale and digging power are on an entirely different plane. They are the primary excavation tool in large open-pit mines, responsible for loading hundreds of tons of rock and/or into those massive haul trucks with just a few swings. The core engineering mechanism is a combination of immense leverage and hydraulic or electric power. Take the Bucyrus RH400, for instance, now part of Caterpillar's lineup, and one of the world's largest hydraulic mining shovels. This machine stands over 33 feet tall, weighs over 1 million tons, and has a bucket capacity of 85 cubic yards. That's enough to hold over 100 tons of material in a single scoop. The power comes from a massive hydraulic system, driven by multiple diesel engines or electric motors totaling over 4,500 horsepower. This system channels hydraulic fluid at extreme pressures, often over 5,000 pounds per square inch, to cylinders that are themselves several feet in diameter. These cylinders extend and retract the boom, stick, and bucket, generating forces powerful enough to tear through fractured rock. The trick is not just the raw power, but the precise control. Operators, sitting high above the ground in climate-controlled cabs, use joysticks to command this colossal machine, effortlessly manipulating thousands of tons of steel and rock. The shovel's broad tracks distribute its immense weight, preventing it from sinking into the loose ground, while its massive counterweight ensures stability as it swings its full bucket. It is a finely tuned instrument of destruction, capable of moving more earth in an hour than 100 men could move in a week. Number 2, the dragline excavator. While mining shovels excel at direct, powerful digging, sometimes the sheer volume and depth of overburden, the waste rock covering the desired ore, requires a different approach. This is where the dragline excavator comes in, a machine that doesn't just dig, but casts its digging power over a vast area. Often seen in coal stripping operations, these are among the largest land-based mobile machines ever built. The engineering genius of the dragline lies in its enormous reach and the elegant physics of its operation. Unlike a shovel that pushes directly into the face, a dragline uses a massive bucket connected by steel cables to a towering boom. The bucket, which can weigh over 200 tons and hold over 200 cubic yards of material, is cast out by releasing the drag cable, letting gravity and momentum carry it across the ground. Once it lands, the powerful drag motors pull the bucket back towards the machine, filling it as it scrapes across the earth. Then, the hoist cables lift the full bucket, and the entire superstructure, weighing thousands of tons, slews, or rotates, to dump the material far away, often creating a new spoil pile. Consider a model like the Marion 6360, affectionately nicknamed Big Muskie, which operated in Ohio. It stood over 220 feet tall, weighed 13,000 tons, and its boom was nearly 300 feet long. Its bucket alone could hold 325 cubic yards of material, roughly equivalent to 50 garbage trucks. The power to swing this immense mass comes from a series of massive electric motors, drawing enough electricity to power a small town. The false belief here is that these machines are simply brute force. In reality, their operation is a carefully choreographed dance between gravity, momentum, and immense cable systems, requiring operators to understand the subtle physics of casting and pulling to achieve maximum efficiency over vast swaths of land. The trick is to not fight gravity, but to harness it. Number 1, the bucket wheel excavator. If any machine can truly claim to reshape the Earth's surface in real time, it is the bucket wheel excavator. These are not merely big, they are mobile landscapes, industrial behemoths so vast they make everything else on this list seem small. Used primarily in lignite coal mining, they are designed for continuous, high-volume extraction of soft overburden and coal. The staggering scale of these machines demands a fundamental re-evaluation of how we perceive heavy machinery. The most famous example, and indeed the largest land vehicle ever constructed, is the Bagger 293, operating in the Garzweiler open-pit mine in Germany. This machine stands over 315 feet tall, nearly as tall as a 30-story building, and measures over 730 feet long, roughly the length of 2.5 football fields. Its operational weight is over 31 million pounds, or 14,200 tons. The core engineering marvel is its massive rotating bucket wheel. Picture a giant, multi-bladed circular saw, over 70 feet in diameter, studded with 20 individual buckets, each capable of holding over 500 cubic feet of material. This wheel spins at a controlled rate, with the buckets continuously scooping up material as the entire superstructure moves forward on gargantuan crawler tracks. The excavated material is then fed onto an internal conveyor system, a network of belts sometimes over 12 feet wide, which transports the earth at speeds of up to 30 miles per hour, eventually dumping it into dedicated spreaders or onto other external conveyors that carry it away from the mine face. The Bagger 293 alone can move over 8.5 million cubic feet of material, that's 240,000 cubic meters, per day. To visualize this, imagine digging a trench over 70 feet wide, 70 feet deep, and over 500 feet long, every single day. This relentless, continuous excavation process is why the bucket wheel excavator stands alone. It doesn't take scoops, it devours landscapes. The engineering challenge is in synchronizing thousands of motors, hundreds of miles of cabling, and vast steel structures to operate as a single, fluid unit, constantly balancing weight, movement, and the immense forces generated by its digging wheel. It is a continuous, moving factory designed to disassemble mountains. The true ingenuity is the relentless pursuit of efficiency on a truly geological scale, converting an entire landscape into a stream of raw material, hour after hour, day after day. It is an act of engineering that fundamentally alters the earth. Every giant machine hides one piece of engineering nobody notices. Subscribe for the next one.